Welcome back, everyone. We're going to be solving LeetCode 21, merge two sorted lists. So we're given the heads of two sorted linked lists called list 1 and list 2. We need to merge the two lists into one sorted list, and the list should be made by splicing together the nodes of the first two lists, and they want us to return the head of the newly merged linked list. So we took a look at example 1. We're given 1, 2, 4, and 1, 3, and 4. We should have an output of 1, 1, 2, 3, 4, 4. So what we're going to do is we'll use a dummy node, and we will have two pointers to keep track of the nodes in both of our lists. So we will say dummy is going to be equal to a list node. We can initially set the value to none, and we will have a current pointer which will point to our dummy node. Okay, so now we need to loop through. We need to do a while loop and loop through while we still have nodes left in our list 1 and list 2. While there are still nodes that we can take and append to our dummy node, we're going to say, okay, well, if the value at list 1 is less than the value at list 2, we're just going to take this node and put it here to be the dummy.next, and then we'll update the pointer to from 1 to 2 in our list 1, and then do our loop again. Then we'll say, okay, is 2 less than 1? It is not, so we're going to take this node, and then we will put it as dummy.next, right? And then we'll just continuously do this until we have nothing left. So like I said, we're going to use a dummy node, and we will have a pointer set to our dummy node, and we will say while list 1 is not none and list 2 is not none. What do we have to do? Well, we have to compare the nodes, right? So we'll say if list1.val is less than list2.val. We just want to set the current.next value equal to list 1. Right, and then we want to update list 1 to be list1.next. So list 1 and list 2 are essentially the heads of our linked lists, and we're going to update the heads to be the next node in the list once we do this operation. Okay, so we'll say else, right? Else list1.value is either, or list 2 value is greater than or equal to list 1, we can do this block. We'll say current.next will be equal to list 2, right? We'll take from the second list. And then we can update our list 2 to be list2.next. And then regardless if either one of these blocks runs, right, we always want to update our current pointer to be the current.next pointer. So let's print out dummy.next just so everyone can see, right? We'll also print out list 1 and list 2. Okay, so our dummy.next node, or our dummy node, right? I printed out dummy, not dummy.next, right? So we've got that initial none node that we put in front. Perfect, and then the next pointer is going to be pointing to 1, awesome, and then we have another 1, right? This is our output list, and then it points to 2, and then to 3, so we're good so far, and then to 4, and then it points to none, and then we can see that list 1 still has one more node in it, while list 2 doesn't have any. So what do we have to do when we run into a case like this? Right, we've exited our while loop, but we still have nodes left. So in order to account for this, whenever we break out of our while loop, we always want to check if there are still elements in list 1, right? So if list 1 is not none still, we can just say current.next is going to be equal to list 1. We'll just take whatever is left of our list and make it the current.next value. And then we will do the same thing for list 2. Current.next equals list 2. And then at the end, we want to return not dummy, we want to return dummy.next because we don't care about this sentinel node in the front. So we'll run this. We pass all 3 test cases. We'll submit. And it does run. Perfect. So what is the time and space complexity for this problem? The time complexity is going to be O of n, right? We're doing a loop through both of these. We're looping through both of these lists at the same time. So that is going to give us a time complexity of O of n. And the space complexity, well, again, time complexity O(n), we're only touching every node one time. And we're doing one loop through it, so O of n. Space complexity, again, you might want to say it's O of n, but it's not. We're adding a singular node, and then we are just creating this new output list from our original input lists. So we're not creating any new data structures, we're just using what's given to us. So our space complexity is actually going to be O of 1 in this case, and that'll do it for LeetCode 21.